So we're looking at solving rational equations using the zero product property. Our first step is to recognize, first off, is there any denominator that will factor? In this case, we just have single terms in the denominator, and therefore we don't have to look at factoring. But then we need to ask ourselves, is there any value of the variable that would make the denominator 0? In this case, I'm just going to put a comma here. We know that x cannot equal 0. And the reason for that is because if x equals 0, then the denominator, in this case, both of the terms with a variable term in the denominator would equal 0. Now our next step is to find the least common denominator of all denominators in the equation. In this case, our least common denominator is going to be x squared. So then we multiply both sides of the equation by x squared, by the least common denominator, in order to eliminate the denominators. So we have 1 minus 2 over x, and that's going to be multiplied by x squared, equals 15 over x squared times x squared. Distributing the x squared on the left-hand side, we get x squared minus x squared times 2 over x is just going to be 2x. And that equals 15 over x squared times x squared equals 15. Now that we have eliminated the denominators, we can put the quadratic equation that results in standard form. And we do that by subtracting 15 from both sides, and we get x squared minus 2x minus 15 equals 0. And then we want to know, since our leading coefficient is 1, can we factor this? We want two numbers that multiply to negative 15 and add to negative 2. Well, that would be negative 5 and 3. So we have x minus 5 and x plus 3. Negative 5 and 3 multiplied negative 15, and they add to the coefficient on the x term, negative 2. You could always multiply back through if you wanted to verify that it's correct. And now we use the zero product property. And to use the zero product property, we set each of our factors equal to 0. So x minus 5 equals 0, or x plus 3 equals 0, which gives us x equals 5, or x equals negative 3. Now, tentatively, this is our solution. As always, we want to check our solution. We do that by substituting into our original equation. So when x equals 5, we have 1 minus 2 over 5. We want to know, does that equal 15 over 5 squared? So 1 minus 2 over 5, that is 5 over 5 minus 2 over 5. And we want to know, does that equal 15 over 25? So 5 over 5 minus 2 over 5, that's 3/5. And if we reduce this other side, 15 over 25, 15 divided by 5 is 3. 25 divided by 5 is 5. So that checks. Now what about when x equals negative 3? So when we have x equals negative 3, we have 1 minus 2 over negative 3. We want to know, does that equal 15 over negative 3 squared? So 1 minus 2 over negative 3, that's the same thing as 3/3 plus 2/3. Minus a negative is plus a positive. We want to know, does that equal 15/9? 3/3 plus 2/3, that's 5/3. And then 15 divided by 3 is 5. 9 divided by 3 is 3. So that solution checks as well, verifying that the solutions to 1 minus 2 over x equals 15 over x squared are x equals 5 and x equals negative 3. Neither one of those is 0, so we're fine as far as the denominators are concerned.